This conference will now be recorded.
Shall we start? Am I audible?
Yes, ma'am, audible.
Right. Okay, good morning to all. Okay, so before getting into today's session, we are going to discuss about the previous day topic. Okay, so what we have seen in the previous class, we have seen about biosignals, neurons, electrical activity of a cell, potential, electrode potential, half cell, motion artifacts, and electrode skin interface. Right. So what do you mean by biosignals? Biosignals are the signals which we are going to extract from human body. Okay, so the signals taken out from a living object is said to be biosignal. So in neuron we have dendroids, isn't it? Axon and dendroids. So each and every neuron will be connecting with other neuron. In human brain we have millions and millions of neurons inside it. The brain unit is called neurons. Okay, so the signals from the brain will be propagated throughout the body through this dendrites. And we have positive charge and negative charge in the neuron. Okay, so outermost part of the neuron possess positive charges and internal body have negative charges. Okay, so when this potential changes, when this positive charge and the negative charge will move from one place to another, then it creates an ionic current. Okay, ionic potential. So we are going to place an electrode over the skin that absorbs ionic current and converts it into electronic current. Your electrode acts as a transducer. Transducer is a device which we are going to convert one form of energy into another form of energy. Okay, so next is what electrical activity at cellular level is classified into two. One is resting state, another one is action state. Okay, so in resting state we have polarization of cell, so there will be no movement of positive and negative charges in the neuron or in the cell. Okay, so that is said to be polarization of the cell. Polarization is nothing but alignment. Okay, so I am aligning positive charge and the negative charge in the cell. So what is positive charge and the negative charge? The chemical substances present inside your cell which acts as a positive charge and the negative charge. Say for example sodium and potassium, fluorine, everything are present inside the human body cell. Right, so each carries individual charges, so that chemical reaction by the application of external force is giving me an ionic current. And repolarization of the cell is nothing but the movement of ions in and out. And we have seen various sources of biopotentials. Okay, so when you're going to place electrons over the skull, then that technology is said to be electroencephalogram. Okay, we are going to measure activity of the brain using electroencephalogram, EEG. Okay, if I'm going to place my electrode or sensor over the skull, then that technology is said to be okay. Yes, where I left, cellular activity and various sources of biopotentials. Okay, so various sources are like electroencephalogram, electrocardiogram, electromyogram, electroretinogram, and electrogastrogram. Okay, so if we want to measure the activity of the gastrointestinal of the body, digestive system of the body, we are going to place electrodes over your stomach. Okay, that is gastrogram, electrogastrogram. And we have seen some characteristics of electrodes and the technologies. Okay, so we have few kind of electrodes, that is surface electrodes, needle electrode, deep electrode, corneal electrode, miniaturized surface electrodes. We have n number of electrodes, each and every electrode having different characteristics in order to give the signal out of human organ. Okay, we should not place a common electrode to all the places of the body, because each and every organ are sensitive to signals. Okay, so that is why we have to place different kind of electrodes over the body to measure the activity of particular organ. And next we have seen some biopotential basics, and Purpose of electrode paste. So electrode paste is nothing but it is like an interface between your skin and the electrode. Okay, so this increases connectivity between your skin and your circuit, electronic circuits. Okay, so this is also used to remove some of the outer cells in the layer of the skin. So if you have any dirt particle present in the skin, your signal extended out of your organ will not be proper. Okay, so in order to avoid those dirt and dead cells over the skin, we are going for electrolyte. Okay, that is paste. And also it reduces artifacts. Okay, the electrode paste is used to reduces artifacts. I have told you yesterday that artifacts are called disturbances. Okay, so when we are measuring some performance of or some parameters of the organ, we should not have any disturbances. Okay, so because it is a vital thing to diagnose the patient whether they are diseased or not. Okay, if we have disturbances in the signal, then the diagnosis of the patient will not get proper. So they will get into an improper treatment. Okay, so that is why we are going to reduce these artifacts. So the movement of electrodes and the movement of patient causes artifacts. Okay, so and also the contact impedance on the dry skin is about 100 kilo ohms and capacitance is of 0.01 microfarad. Okay, so this is used for proper connectivity between your skin and your electrode. And the material where we are going to prefer is coal tar pitch. Okay, anthracite and coal tar pitch. And also this is of the material graphite. Okay, graphite material can conduct current. So I have given you example yesterday like pencil. Okay, in the pencil lead we can able to conduct current, so because that is made up of graphite. Okay, I have given you a few videos, YouTube videos link, and the definition of potential, action potential and resting potential. Okay, from the name itself it denotes the resting potential is nothing but there is no movement of any charges between your cell, in and out of your cell. That is said to be resting potential. What I mean by action potential, your cell is get into action by exchanging positive charge and the negative charge because of this application of some external sources. Okay, external sources will makes your ion to move from inside of the cell to outside of the cell. Okay, so we have fluid like structure present in the cell so that the charges can easily move from one place to another. Whenever the ion movement or applicable or ion movement are obtained, then we are obviously get ionic current. Okay, so I have given you example, pretty good example like a p-n junction diode. Okay, the p-type conductor and n-type conductor are connected with each other. The junction will be present at between, and the depletion region will be developed without the application of supply voltage. When we increase the supply voltage to the p and n-type material under forward bias condition, what happens? The p-type charges, positive charge and the negative charge move opposite to each other, so that there is a hole pair, electron hole pair recombination takes place. That depletion region vanishes and that semiconductor starts conduction. Correct. So in similar way here, I'm going to apply an external source so that the positive and negative charges of cell will move from one place to another, so that I can extract signal out of my human body. Okay, that is a typical biosignal, right? So we have seen all those things yesterday's class. And electrode electrolyte interface example, metal and your electrolyte. Okay, the movement of oxidation and reduction process. Okay, the gain of electrons and the losing of electrons. Okay, that is oxidation reaction causes atoms to lose electron, reduction reaction causes atom to gain electrons. Okay, and we also have seen polarizable and non-polarizable. Polarization is nothing but the alignment of something, and here non-polarizable electrodes is nothing but we are having charges. Okay, in polarizable electrode we don't have any charges. In non-polarizable electrode we have charges. Okay, here your non-polarizable electrode acts as a capacitor and your polarizable electrode acts as a resistor, because there is no charge carriers across your cell. That is called the operation similar to your resistance. That is why it is called resistor. Okay, so next we have seen motion artifacts consideration. So in order to consider motion artifacts, we must follow good adhesive connection to skin cleaning and floating electrode. The material, electrode material should be good adhesive so that the connectivity will be get proper results. And we have a clean skin. Okay, skinல dirt இருக்கக்கூடாது. I should clear my dead cells and dead particles in the skin. Okay, and today's session we are going to look at electrode potential, classification of electrodes, functions of electrodes, and biopotential amplifiers. Okay, so in electrode class potential, okay, what do you mean by electrode? It is like a transducer which I am going to place over the skin. It gets signal from the body and converts that signal into your electronic signal. So the ionic signal getting from the body will be converted to electronic current. So yeah, ionic current converted to electronic current by your transducer. So here your electrode acts as a transducer. Okay, so this is electrode potential and the classification of electrodes, function of electrodes, and biopotential amplifiers. So next is what? This is already we have seen this diagram. You have polarization of the cell. The alignment of positive and negative charges are retained in the same place. And next, depolarization of the cell. I am going to have some external source for making my resting potential into active potential. And here we have repolarization of the cell, and finally we get action potential. The movement of positive and negative charges gives me a voltage. Okay, that is a biosignal. Here you can see the negative signal, negative particles are present inside the cell. In this diagram, you can see the negative charges are present outside of the cell membrane. Okay, so inside you have positive charges. So the exchange of ions gives me a current, action potential, ionic current. Okay, so next is what? The classification of electrodes. So electrodes are classified into some 5 types. Okay, so number 1 is microelectrode, depth electrode, needle electrode, surface electrode, chemical electrode. Okay, so under microelectrode we are having furthermore classification like ventilate and micropipette. And depth, there is no classification, depth and needle. And surface electrode, we have classification like suction, multi-point, floating surface electrodes. Under chemical, we have hydrogen, practical reference, pH, PO2, and PCO2. These are all some classification of electrodes. Okay, so microelectrode, depth electrode, needle electrode, surface electrode, and chemical electrodes, basic electrode types. Okay, individual electrode occupies individual role. Okay, so we cannot place surface electrode for skull. We should go for depth electrode or needle electrode for measuring your brain activity. Okay, and similar way you should not use this depth or needle electrode to measure your function of heart, because this needle electrode will harm your heart. Okay, because the very soft muscle present in the human body is heart muscle. Okay, cardiac muscle, and each and every organ occupies important function, and we are going to extract the signal out of it through different kinds of electrodes. And first one is microelectrode. Okay, so microelectrode, from the name itself it denotes it's used to measure bioelectric potential near or within a single cell. Okay, so you know the size of a single cell, it is under nanometer. Okay, so if I want to study about the cell, single cell operation, I should go for microelectrode. Okay, microelectrode is very small in size. These are all called intracellular electrodes. Okay, so next, depth and needle electrode. So this is used to measure bioelectric potential of highly localized extracellular regions in brain. So depth and needle electrode can reach your brain. Okay, after your skull you have your brain, right? So in order to reach your brain, I go for depth electrode and needle electrode. Okay, needle electrode na இன்னும் வந்து ஷார்ப்பா individual neurons function it will measure. That is why we have depth and needle electrode. This is highly localized extracellular regions in brain. And next is what? Surface electrodes. Surface electrodes are used to measure the potential available from the surface of the screen. So you can use the surface electrode for cardiac operation, cardiac measurement, or some myogram, that is muscle operation. Okay, so we can also take huge signals, huge portion of your body will covered using the surface electrode. And next, neural electrodes and microelectrodes. Okay, so this is used to measure potential within a single cell. Okay, microelectrodes, as we can see in this presentation, microelectrode are used to study or measure biopotential signal within a single cell. That is same here, neural electrode or micro electrode. So this is used to measure potential within a single cell. It is having smaller in diameter. It will never ever damage human cell. Okay, the micro electrode will never damage human cell. It is classified into two. One is metallic and another one is non-metallic. Okay, so non-metallic is also called micropipette. So metallic electrode. So under your neural electrode, we have this classification metallic electrode. So this metallic electrode is used for taking out signal, and the tip of this particular electrode is like fine tungsten filament material, stainless wire material. Okay, because it is going to measure a single cell. Okay, so the sharpness of this particular electrode will in a few in the material like fine tungsten filament. Okay, and is measured using two electrodes. Okay, we cannot able to take signals out of your cell directly. I should have some reference voltage or threshold voltage. Okay, so two electrodes should be there to compare the signal, whether I have taken the signal to my right point or not. Okay, whenever you're going to compare the signal, then only you can easily diagnose the patient. If the signal extracted from the human body is exceeded or decreased, so that the disease will be diagnosed. Okay, so here we have two electrodes. Okay, so micro electrode and reference electrode. Okay, this micro electrode is placed over your single cell and reference electrode placed in your other body. I mean, it is acts as a threshold or reference voltage. And here neural metal electrode is used to studying the electrophysiological of excitable cells. From this diagram, you can easily understand here. Look at this diagram. You can easily understand this is your single cell, but has cytoplasm and nucleus. Okay, this is single cell. I'm going to measure single cell operation, whether it is working properly or not. Okay, this is my metal electrode. Okay, inside the electrode you will have capacitors. Okay, series of capacitors. This is your metal rod. We have insulation. Insulation எதுக்கு நான் யூஸ் பண்றோம்னா கண்டக்ஷன் ஆகக்கூடாது. உங்களோட பிளட்டும் உங்களோட கொடுக்குற நீடலும் கண்டக்ஷன் ஆகக்கூடாது. Okay, so here we have positive charge, and outer part is positive charge, inner part is negative charge, and we have reference electrode. We can place the reference electrode over any part of the skin. So I am going to take the signal out of single cell and comparing with my reference signal. Okay, this is given as input to my amplifier to boost my signal. Okay, this is the circuit, and here we have equivalent of my micro electrodes, metal micro electrodes. Okay, so your capacitors and resistors plays a major role. The combination of RC network gives an equivalent circuit to my metal micro electrodes. Non-metallic micropipette. So second type of your neural electrode is non-metallic micropipette. So it is used to measure the potential within the single cell. It is also used to measure a single cell, right? So it is non-metallic. Okay, it is filled with an electrolyte that is compatible with the cellular fluids. It is not a metal. This is non-metal. Okay, it is filled with electrolyte. So this is your glass intracellular microelectrodes. Okay, so this is the glass, this is your cell. So cell is having positive charge and the negative charge. Inside your cell you will have a negative charge, outside of the cell you will have positive charge. Okay, so this is glass electrode, non-metallic electrode. So inside this glass electrode you will have tip, tapper. This is an internal electrode. This is glass. This is filled with electrolyte fluid. Okay, electrolyte in micropipette, and we have taken one signal out from the glass electrode, and it is compared with the electrode, reference electrode. Okay, here we are going to place some amplifiers. In the previous diagram, you could see this is your metallic electrode or needle mari irukum. This is metallic, and here you have glass paper. It is like a glass material, not a metallic material. This is non-metallic glass material. Okay, so in the same way we have electrode inside your glass material, so that it will extract the signal from this individual cell and taken to my amplifier. Here we have already reference electrode. This reference electrode voltage is also compared with the amplifier. Okay, so the difference between those two signal will use it for diagnosing the operation or activity of the individual cell. This is the electrical equivalent, okay, of your glass intracellular microelectrodes. And next is metal plate electrode. Okay, this is made up of German silver, and it is used for placing over the chest. Okay, the thickness of the foil allows to conform to shape of the body surface. So இது வந்து cardiac இது யூஸ் பண்றது, மெஷர் பண்றதுக்காக யூஸ் பண்றது metal plate electrodes. Okay, chest use பண்றது, recording ECG measurement, right? So ECG is nothing but electrocardiogram. We can also use the surface electrode for measuring your myogram, is electromyogram, to get the proper function of muscles. Okay, so muscle contraction, extraction, adukapra muscle spasm, or everything can be measured using the surface electrode as well. Okay, so this is two type of surface electrodes. Number one is what metal plate electrode used for application to limbs, and B is what your metal disc electrode applied with surgical tape. Okay, so surgical tape na tape pot otirvanga. Okay, so this is metal plate electrode. And next comes, we have disposable foam pad electrodes. So from the name itself, it shows that it is going for disposable. Okay, one use electrodes. Okay, so here you will have a top and a bottom structure. In the top you will have a snap and foam pad. This is called foam pad. You could able to see this a plastic rubber type pad in hospitals. Okay, so ECG எடுக்கும்போது பார்த்திருக்கீங்களா, round ஒன்னு வச்சிருப்பாங்கல heart பக்கத்துல. Yes, or if you go for any physiotherapy treatment, okay, the physiotherapist will place these kind of electrodes over the muscles. Okay, to give ultrasound or some frequencies to make your muscle relaxed. Okay, contracting muscle get relaxed. Okay, so this is a foam pad, this is a top view, this is bottom view. Okay, so this is metal disc and or electrolyte. This is used to conduct your frequency to your muscle. This is adhesive tag of surface of foam pad. Okay, so இது ஒட்டுற மாதிரி adhesive material தான் இருக்கும். And this is disposable, so we can use only once. If you use the next time, it will not stick onto the skin properly. Okay, so this is also used for measure electrocardiograph. And next is what? Suction electrode. So suction electrode is a metallic suction electrode, is often used as precordial electrode on clinical electrocardiographs. Okay, so surface electrode, suction electrodes are used for measuring your ECG. Okay, cardiac muscle activity will be measured using this suction type electrode. Okay, so no need for strap or adhesive. Adhesive na glue material. Okay, gummer irukku, so that is to be adhesive. No need for strap or adhesive. It can be used frequently. We can place this suction electrodes. It is like a air pump மாதிரி இருக்குல்ல, இப்போ நம்ம எப்படி சொல்றது, ஏர் டைட் கீழே நம்ம டேபிள்ல வச்சுட்டு லாக் பண்ணா லாக் ஆயிடும்ல, அந்த எப்படி சொன்னா வெஜிடபிள் கட்டர்ஸ் எக்ஸாம்பிளுக்கு சொல்லட்டுமா, வெஜிடபிள் கட்டர்ஸ் ஆர் சம் வைசஸ். Okay, so இது வந்து ஏர் லாக் suction electrodes. Okay, so no strap or adhesive required. Precordial chest measurement can be used only for short periods. Short period மட்டும் தான் அது வந்து லாக் ஆயிட்டு இருக்கும், இல்லனா அது வந்து கொஞ்சம் லூஸ் ஆயிடும். Okay, so this is suction electrodes. Next, floating electrode. Floating electrode, we have many different types. Okay, so one among that is floating electrode. This is your double-sided adhesive tapering, and this is your floating electrode. And here we have structure, internal structure of floating electrodes. Okay, so in the structure we have your electrode. This has your layer. So this is foam pad. You are having capillary. Capillary we have germinating layer. So in order to this is extract the signal out of it. Signals when taken cellular material through your floating electrode. Okay, here they have coated silver chloride. Silver chloride is a very good conductor of current. From human. Okay, so cross is able to see the bottom view of floating electrodes. Okay, so swimming in the electrolyte gel not in contact with the skin reduce motion artifacts. So this is used to swim in the gel. Okay, this electrode will move from one place to another. Okay, this should not be used for measuring heart muscle, because heart is very important organ, we should measure precisely. So this can be used for muscle contraction or spasms like that. Okay, so because it is swimming over the electrolyte gel, floating electrode will move, tends to have a movement from one place to another. Okay, and next is what your flexible electrodes. Okay, so flexible electrodes, you can fold this electrode, that is flexible body surface electrodes, carbon filled silicon rubber electrode, flexible thin film neonatal electrode. Cross sectional view of thin film electrode is shown in the figure B. Okay, so this is the electrode where we can able to flexible, we can uh, twist or we can fold, we can do anything with this electrode. Okay, this is flexible electrode. And used for newborn infants, compatible with X-rays. Okay, this electrode is very sensible and it can be used for measuring organs for infants. Infants is nothing but kids. Okay, ரொம்ப குட்டியா இருப்பாங்கல்ல, very small children and kids. We are using this flexible electrode. Newborn infants. Okay, if the baby is not under proper weight, we are going to place that baby into incubator. Okay, and also we are going to place some more electrodes over the baby. Correct. In order to measure the heart function or some other parameters of human, the baby, we are going to place electrodes over the surface of the infant. Correct. So that is what flexible electrode. It will never ever harm your infant. Okay. Next is internal electrode. Okay, so internal electrode, fetal scalp electrode. This electrode is very sensitive again, which is used for fetal scalp electrode. Okay, this electrode is used for detecting fetal electrocardiogram during labor by means of intracutaneous needles. So if a person is getting pregnant, the baby in the womb, okay, the heart function that fetal will be measured using this internal electrode. Okay, so we have suction cup, electrode, lead wire, suction cup, electrode, and lead wire. This is going to be placed to the infant. Okay, so this needle-like structure is given to the baby so that the signal will be taken out. Okay, so here you can see suction electrode, cross-sectional view of suction electrode in place, showing penetration of probe through epidermis. And third one is helical electrode, which is used for, which is attached to the fetal skin by corkscrew type action. Okay, so this is corkscrew type action. All these three electrodes are used to measure the fetal electrocardiogram. Fetal is nothing but baby which is under pregnancy. Okay. Next is implantable electrodes. So implantable electrodes, you can easily understand implantable electrodes, where we are going to place the electrodes inside our body through surgery. That electrodes are used to trigger your muscles, make your cells into active state. Okay, so first is what your wire loop electrode, where you have insulation at the outside and you have wire in the inside. Okay, so next is what the B diagram. This is P. This is silver sphere cordial surface potential electrode. Third one is multi-element depth electrode mounter. Okay, so all these three are used to implant inside our human body in order to trigger our muscle or cells or organs of the body. Okay, implant and body kulle vekkathu. Next is what? Electrode arrays. Okay, so a number of electrodes are putting in such a way, is arranging in such a way that I can able to activate more number of cells at the same time. Okay, this is the figure A shows one dimensional plunge electrode array, 10 mm long and 0.5 mm breadth. Okay, so this is like a needle structure. We have put a more number of an array, so more number of electrode in a single arrangement, so that it is used to extract the signal out of many cells at the same time. Okay, this is electrode arrays. You could see here, this is exposed tip. This is going to measure activity of cells. And next, biopotential amplifiers. Okay, so this is the last thing, amplifiers. What do you mean by amplifiers? Amplifiers is nothing but a device, electronic device, which is used to boost your signal. Okay, so if you have a minimum signal which physician cannot able to diagnose the patient, we are going to boost the signal. Okay, so to magnify the signal taken from the body organ so that the physician can easily diagnose and give treatment to the patient. Okay, so that is the application of amplifiers. Excuse me. So amplifiers is used to boost the signals. Okay, so that is why we are going to give the electrode output to the amplifier so that the electrode signal will be amplified and processed in electronic devices, that is instruments of biomedical field. Okay, these are very important part of modern medical instrumentation. Instrumentation is nothing but the electronic machines which is supposed to showcase or display the patient's condition. Okay, so that is called instruments. Every medical instruments are belongs or based upon the electronic components and technologies. Okay, electronic technologies are used to build the instruments present in the medical field. And we need to amplify biopotential which are generated in the human body at low levels with high source impedance. Okay, this is used to strengthen the signal. Avladhan. I'm going to make my signal into a strength one so that I can easily diagnose. Avladhan. Okay, so if you get the signal in microamps, that cannot be used for diagnosing operation. Okay, if you boost that microamps into milliamps or amps, then I can easily diagnose the patient. Okay, this is application of biopotential amplifiers. Right, so do you have any doubts so far? Any doubts so far? Right, it seems no doubt. And I'm continuing my lecture. So this is basic requirement of biopotential amplifiers. Okay, what are all the necessary requirements for biopotential amplifiers are? It is used to increase the amplitude of weak electric signal of biological origin, typically process voltages, but in some cases also process currents. Okay, it is used to increase the amplitude of the signal, biosignal, and typical bioamplifier requirement is impedance. Okay, should have high input impedance that should be greater than 10 megaohms. Okay, and the safety measures for this biopotential amplifier is used to protect the organism being studied, and we have to properly design to prevent macro and micro shocks. Okay, so all amplifiers, all electronic circuits will work with current, so we should be very careful of not having any micro or macro shocks to the patient. Okay, so machines then continue, so that there is a possibility of having shocks, so that should all the electronic instruments present in the medical field should be properly grounded. Okay, so isolation and protection circuitry to limit the current through the electrode to safe level. Okay, so when it reaches the threshold level, your patient will get affected with the current shocks, micro or macro shocks. Okay, that should not be recommendable. So the proper ground and proper terminal of your electronic instruments are should be taken care of. And next we have output impedance of the amplifier should be low. We have high input impedance of the amplifier and low input impedance of amplifier. This state should be maintained properly. Okay. And also we have a signal biopotential or typically less than millivolt. Okay, millivolt தான் இருக்கும், அது நம்ம வோல்ட்டா மாத்தணும், சரியா? So and we have high common mode rejection ratio so that errors will not be present in the signal, and rapid calibration of amplifiers in the laboratory conditions. So the output of the amplifier is connected to the display unit so that the calibration of the parameters will be taken place to diagnose the patient. And also we can adjust the gain using some scales for calibration of your patient's parameter. Okay, so calibration is nothing but measurement. And the next is what? Interference reduction techniques. Okay, we have few interference reduction techniques. One is common mode voltages. This common mode voltage is nothing but the two electrode, the reference electrode and the active electrode are having equal value. Okay, so then the solution for that is amplifier with a very high common mode rejection and eliminate the source of interference. Okay, so these two solutions are possibly obtained out of your amplifiers. Okay, and also we can able to eliminate the interferences using electrostatic shielding, magnetic shield, and proper permeability materials. Okay, so and also we can reduce lead loop area by having twisted cables. Okay, magnetic flux will be reduced using twisted cables. Okay, whenever you are going to use or electronic instruments to the patient, each and everything should be monitored properly. Okay, so the cables, the supply voltage, the ground signal, okay, the flux signal, magnetic flux or electronic flux, and the shocks, everything should be carefully deals with. Okay, and this is one example for your amplifiers, biopotential amplifiers. This is like we have two electrodes that either hand. This is an electrode, here we have one electrode, and here we have one more electrode. Okay, this is a typical diagram for your measurement of cardiac muscle. Okay, so this output is given as input to my one amplifier. This is non-inverting amplifier, and here we have taken another signal from hand on inverting amplifier, and we have taken this as feedback. Series of resistors are here, and from the right leg I'm going to place a resistor in series with the electrode, and it is given as input to this particular place, and I have taken that to by feedback of another auxiliary amplifier, so that the signal will be taken out from the patient through electrodes and given as input to the amplifiers. Okay, so in the electronic circuits we have n number of resistors and capacitor combinations where it gives me a high electrode signal. Okay, so always we should prefer negative feedback of amplifier because it reduces your errors and increases stability of your amplifier. Okay, this is one typical example for using electronic circuits. Okay, so that the session is over. Do you have any doubts so far? Okay, what do you mean by electrode? Can anyone volunteer yourself and answer me what is electrode? Electrode. Gunasekar. Gunasekar. The Jagdish Prabhu. Jagdish Prabhu.
Yes, ma'am.
Salut Jagdish, what is electrode? Define electrode. Did you understand today's topics?
Yes, ma'am.
Yes, what do you mean by electrode?
Electrode. It is an electrical conductor, ma'am. Uh,
Yes, proceed. Jagdish,
yes, ma'am.
yes, what is the application of electrode?
Used in batteries to store electricity, ma'am.
Electrode is different, electron is different.
It is used to uh,
You have mobile, right, in your hand or system.
yes, ma'am.
Correct. Put this
Yes, ma'am.
electrode and surf it using Chrome or something. For the past 2 days, we have discussed about the electrode and the operation.
Provide current through non-metal objects, ma'am.
Yes,
Electrodes are used to provide current to non-metal objects.
provide current signals. Okay, so in medical field, this electrode is used to extract the signal out of human body. It takes ionic current from the body and converts into electronic current. It acts as a transducer. Okay, Jagdish?
Okay.
Well tried. Thank you. And I
Thank you.
need Jeevanandam. Jeeva,
Yes, ma'am. Yes, ma'am.
tell me the classifications of electrodes, Jeeva.
Really?
Classifications of electrodes. What are the classifications of electrodes? Ready? Next question is for you. Yes, Jeeva, are you there? If you know the answer, put it in the chat box as well. Kavin Chakravarti, respond me. Classification of electrodes. Is Kavya Darshini. Kavya. Yes, Kavya. Classification of electrodes. If you know the answer, you can put it in chat box. Gopika. Gopika. Yes, Gopika. Define half cell potential. Define half cell potential, Gopika.
Ma'am, it refers to the potential developed at the chemical cell.
Your voice is cutting out. Come again.
Ma'am, it refers to the potential developed at the electrode, ma'am.
Very good. Developed from the body to the electrode. That is said to be half cell potential. Okay. Good answer. Thank you, Gopika. And the next question goes to Akalya. Akalya. Yes, Akalya. Define biopotential amplifiers. Biopotential amplifiers. Used to boost signal strength. Good answer. Very good try. Very good answer. Thank you, Akalya. And Achat Roshan. Arshad Roshan, what are the basic requirement of biopotential amplifier? What are the basic requirement of biopotential amplifier? You should have high input impedance, low output impedance. Signal strength should be in proper way. It is in terms of millivolt, and we should reduce artifacts and reduces noises. Okay, so few requirements are there in biopotential amplifier, and proper insulation and proper maintenance of the instruments should be taken care of, so that the micro and macro shocks will not affect the patient. These are all basic requirement of biopotential amplifiers. Okay, so in from next class, if I call out a person who is not going to answer, respond me, I'll mark you as absent. Simple as like that. Okay, class dispersed. Thank you.